Hello students, today we are going to see the topic continuity and differentiability. Continuity and differentiability. So this is the topic we are going to see. So before entering into this topic, we'll see what is the weightage for second PUC. Okay. So from this topic, we are going to get part A, it's a 1 mark question, we'll get 1 question. Part B, 2 mark questions, you will get 2 questions from this. Part C, 3 mark questions, you will get here also 2 questions. Part D, 5 mark questions, you will get 1 question from this. Part E, 4 mark question, 1 question you get. So totally you will get 1 mark, 2 into 2, 4 mark, and then 2 into 3, 6 mark, and 1 into 5, 5 mark, and 1 4 mark. Total together you are getting 20 marks from this topic. So it's a so important topic it is. From this you are getting 20 marks in the final examination. It is one of the topic you can say in all the parts of the question paper it will appear. Okay. So as per the PU board, it is 19 clock hours of teaching as per the PU board rules. Okay. So now we are going to this topic continuity and differentiability. For this we have to recapitulate the limits what we have learnt already. Okay. So students, what I expect from you is when you are taking this session, you just sit in a proper place and have a notebook, note down and feel like you are in the class. Otherwise you won't get the knowledge which is taught to you here. Don't see like normal videos. Take it as it's a video for the class. Okay, right. So we see the recapitulation of limits, what we have learnt in first PUC. Okay. So when you are entering into this topic limits, here one point you need to understand the limiting position. Limiting position. This is the word you need to understand. Limiting position. What is this limiting position? Suppose, for example, if you take, you are writing 9 after the decimals, keep on writing 9, 9, 9, like this, you are keep on writing. Okay. So you keep on writing. So finally, what is the limiting position of this process? That means how many 9s you write after this decimal, but still it is coming close to 1 only. It never equal to 1. How many 9s you write it? So on, so on, so on, like that. How many 9s you write it? But finally, it never be 1. But it is coming close to 1. That's it. How much close means we can't tell. But it is coming close to 1. That's it. It's coming very close to 1. That means the limiting position of this process of writing 0.999 like that, it finally comes close to 1. So then how we write it is like this, coming close to 1. That means how much close means we can't tell it is. Okay, this is one of the good example to understand the limiting position. And one more example I want to give it to you. Suppose we have a circle. We have a circle. Suppose we have a circle. In this circle, we are going to insert the polygons, n-sided polygons. Okay. Suppose first I have I am just inserting the polygons here. Okay, how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so with this 11 suppose. So 10 or 11 sides are there now. Okay, so if you keep on increase these sides, suppose you increase it to 100 sides, this polygon, what do you have inscribed in this circle? Suppose it's 100 sides. Okay, 100 sides you inserted. So maybe it's very close to the circumference, right? It's very close to the circumference. Suppose it's 100 sides. Okay, fine. Suppose if you take 1000 sides or 10,000 sides polygon, then what happens? What is the limiting position of this process? That means inscribing the polygon, the n-sided polygon in the circle, almost what it is? It is the circle itself. Okay, we can't distinguish what is the circle, what is the polygon there. The limiting position of the inserting polygons in this circle, okay, inscribing in the circle will be almost circle only, right? I hope you understand these two examples, right? This is a understanding limiting position. Okay, then I will come to limit now. So when we come to limits, here also I want to tell one point. So as our sense how it works, the same way we have to work for the limits also, right? So suppose I take one example just to explain it to you. Suppose 5 friends were there, A, B, C, D, E, some 5 friends were there, and A and B are very close friends. They both were very close friends, and C, D also friends to him. Okay, right. Now there is a situation come, like A got some very important theoretical point. That means they were all working research work they are doing. Okay, so the person A, he got some result. First he want to share it with the person B now. Okay, he want to share it with the person B, but at that time he is not there. So then what A person will do? Okay, the person A, what he will do it? Then what the sense says that you may say that phone is there, no sir, we can call him. Okay, right? Suppose phones are not there, we just assume like that. You may say that phones are there, right? Phone is not there, suppose. It may be before, okay, like 1900 years before, suppose. Okay. Now what a person will do? Just common sense, what it says, he will approach the person C, because he is in reaching okay, reachable distance. So he came to C and he asked where is B. Okay, he might have told that he went to some chemistry lab. He went to chemistry lab. He is working there. Okay, the C person told. And meantime he asked D also. Okay, so while he is going, he asked D person. Then the D person replied that B is there in the playground. He is doing exercises. Okay, so he is doing his exercises, he told. And then again on the way he met E also. Then he asked where is the person B, and then he told that he is there in the canteen, he is eating. Okay, so these things the person A got from C, D, E, the replies like this. So one person about B, they are saying he is in the chemistry lab, and person D is saying he is in the playground, he is doing some warm-up exercises, and the person E, he told that he is there in the canteen eating. Okay, so 3 different answers he got, right? So that means what he think about B now? Generally what our sense says that where this fellow is. Okay, so then we'll wait for him like that. That means where he is, the B person, he is unable to identify now. right? Because three persons given different answers here. So one person saying chemistry lab, one person saying playground, one person says that canteen. What is this? Okay, he will wait, let him come, right? Another situation came. Again, another situation came. Again, he got some result, theoretical result, whatever he is doing research, he want to share with his friend B. Okay. Then now he came to, again the same thing happened here also. The person B is not available with him. Okay. Then he will go to the person C now. He will go to the person C because they are all, every time CDs are available to him. We just think like that to understand. Okay. So he came to the person C and asked, where is this fellow B? I want to share him some theoretical result what I got. Okay, so the person C replied, this B fellow is there working in the chemistry lab. So he told that just I saw in chemistry lab, he is working there. Okay, then he asked D also. In the meantime, while he is going, he met D person and asked, where is this person B? Did you saw him? Yeah. So he told that he is there in the chemistry lab. Right? And again, in the meantime, he asked person E also, because while he is going to that place, he met these persons. Okay? So he asked E, did you saw this person B? Yeah, he is there in the chemistry lab. He is working there. So now what A will do? He feel very happy, right? So he got the answer that B is there in the chemistry lab. B is there in the chemistry lab. Straight away he will go to the chemistry lab and he will discuss with him. So from these two situations, what do you understand? Okay, when CDE given different opinions, he is unable to identify where this person B is. But the second situation time, all the three persons given same reply. That's why he can conclude that the person B is there in the chemistry lab. He is able to find out the nature, or we can say the behavior where the person B is present. Okay, right? So these are the two examples I want to give it to you to make some sense to understand the limit. The same concept we are going to apply in limit also. Okay, I take an example. Okay, so y is equal to x square, some function I take it. Y is equal to fx is equal to x square. Okay, this is the function I am taking. You all know its graph, right? Y is equal to x square graph. How it will be? It is x axis 0, x dash, y, y dash. So y is equal to x square. Here it comes like this, right? This is a y is equal to x square graph. Now you observe it in the real line. In the real line, you can approach a number in two ways. Okay, so like the example which I explained to you, A, B, C, D, E. Okay, there the person A got three sources to reach, okay, to inquire about person B. But now here at 0, so when you take this 0, this, okay, you can approach this 0 in two ways. One is from right side and one is from left side. When you are coming close to 0, what do you observe? The x square also coming close to 0 here. The x square is also coming close to 0. From this side also, see that. Whenever x is coming close to 0 from left side, the x square also coming close to 0 it is. Okay, right? So that means what we can say is, this is the limit. Limit fx, when x is coming close to 0, is coming close to 0 it is. Actually, it is a, we should not write exactly if we say equal to, we should not write, it is approximate value it is. Okay, when limit x is tending to 0, fx is coming close to 0. Okay, it's coming close to 0. But For our convenience sake, we write it's equal to 0. But students, you remember that it is not exact value. It is the approximate value, right? So the limit of this function fx when x is coming close to 0 is 0. That means, in other words, we can say that when x is moving around 0, when x is moving around 0, the y is equal to x square is moving around 0 only. So that means when x is moving around this 0, the y values is also moving around this one. Okay, we can say like that. So that means here it is, okay, right? So limit extends to 0, fx is 0 now. So another example, we take y is equal to mod x. Y is equal to mod x. We take it y is equal to mod x. You all know it's a familiar function to you. Okay, y is equal to mod x. So we will take x is not equal to 0. We will mention it. X is not equal to 0. Then how the graph will be? So how about the graph? Because it's not 0 is not present. So then there will be a hole here. Okay, because you know the graphs, so that's why I am taking it granted I am drawing here. So this is a y is equal to mod x graph. Y is equal to mod x graph. This is a simple graph. Y is equal to mod x. X not equal to 0. But I want to know what is happening to this function at 0. Okay, exactly at 0 we may not identify it, but we can approach to 0 from either from the right side or from the left side. Okay, you can come close to 0 from left and from right also, right? When you are coming close to 0 from right side, okay, what happens? The y value is coming close to 0. So when you are coming like this, coming close to 0 from right side, then y value is coming close to 0, right? And then same way when x is coming close to 0 from left, then also the y value is also coming close to 0. That means what we can conclude now. So limit of mod x or the function fx when x is coming close to 0 is going to be 0 now. That means when x is moving around 0, the y value is also coming close to 0. So we call 0 is the limit of this function. Okay, but exactly at 0 what is happening means we can't say. Okay, exactly what is happening to this function at 0 we don't know, because the function defined like that, y is equal to mod x when x is not equal to 0. At 0, exactly 0 I can't say, but limiting value I can say it's coming close to 0. You have to understand this difference. So there is a functional value and there is a limiting value. Okay, functional value means exactly when you substitute that point in that, what the value you get, the output, that is called functional value. And limiting value means when x is coming close to a, the fx is coming close to some value, that approaching value we call it is a limit. Okay, so and one more, the good example I am going to explain, with that you may understand better the limit. In this entire first session I am going to give the recapitulation of limit what we have learned in first PUC. So another good example I am going to explain. With this you will understand the complete concept of limit. X square minus 9 by x minus 3, x not equal to 3. So this is the function I am taking. Y is equal to fx is equal to x square minus 9 divided by x minus 3 when x not equal to 3. They have given like this. Okay, now I need to find out limit x tends to 3 fx. I want to find out limit x tends to 3 fx, right? Suppose if I substitute x is coming close to 3, x square minus 9 by x minus 3, if I take it, just I substitute 3, what happens here? 3 square minus 9, because when x is coming close to 3, x square also come close to 3 square, definitely. I just substituted. What happens to this? I am getting 0 by 0. 9 minus 9 divided by 3 minus 3, 0 by 0. It's a indeterminate form, we call it this. It is a indeterminate form. But now, somehow we have to work it out. X is coming close to 3, fx. What happens to this fx? We need to find it out. Okay, I simplify this function. Y is equal to fx is equal to x square minus 9 by x minus 3, x not equal to 3. This x square minus 9, you can write it as x square minus 3 square divided by x minus 3. So, x minus 3 into x plus 3 divided by x minus 3. It's already mentioned that x is not equal to 3. When x is not equal to 3, x minus 3 cannot be 0, right? So, that is why you can cancel this x minus 3 now. Because when x is 3, you cannot cancel these two. Why? Because when x is 3, it becomes 0. This is also 0. 0 by 0 it is. But here the condition x is not equal to 3 is there. That is why we can cancel these two things. X minus 3, we can cancel it. So, we will get x plus 3. So, y is equal to x plus 3 when x is not equal to 3. It is a straight line. Y is equal to x plus 3 is a straight line it is. So, we draw this. So, y is equal to x plus 3 is a straight line. You all know that when x is minus 3, you will get 0, right? When x is minus 3, you will get 0. So, you will get a straight line like this. I am directly drawing like this. Okay. So, at minus 3, you will get 0. Okay. Somewhere 3 is there, we just assume. There will be a gap in this place. Why? Because when x is not equal to 3 it is. When x is not equal to 3, y is equal to x plus 3 this is. So, when x is 0, this value is 3. Okay. And this is going to be 6. This is the y value here. Okay. So, what is the thing we need to do here? See, exactly at 3 we don't know what happens, but we try to find out. We try to find out what is happening to this function when x is coming close to 3, we try to find out. Okay, so we can approach this 3 in two ways. One is from right side and another one is from left side. Okay, so right approach we denote like this. X is coming close to 3 plus like this, 3 plus. Okay. 3 plus meaning is what? You are coming close to 3 from right side. And left approach we write like this. X tends to 3 minus. Don't confuse. 3 minus means, okay, coming close to 3 from left. But some students they will confuse that it is minus 3. No. Okay. You are coming close to 3 from left. Right. So, how we will approach? In a detailed way we will see this. Here I take x, y is equal to x plus 3. I am coming close to 3 from right side. Coming close to 3 from right side. That means we take the value something 3.1 I will take here first. 3.1. Then what will be the y value I get? What will be the y value? 6.1 I get. When I take 3.01, then what I get? The y value 6.01 I get. When I take x is equal to 3.01, then I get 6.001. So 3.0001 you taken. So then 6.0001. If you take 3.401, then you get 6.401 you get, right? So that means when you are coming close to 3 from right side, the y is coming close to 6. See that the value is keep on decreasing, 6.1, 6.01. It's keep on decreasing, coming close to 6. What do you observe now? So, when x is coming close to 3, the y value is keep on decreasing and coming close to 6 here, coming close to 6 in this place. Okay. So, that means what I write now, how I write this, I will write the limit of f(x) when x is coming close to 3 from right side is coming close to 6, right. This is the limit, we call it is right hand limit. What we call it is, it's a right hand limit. The same way, you are coming close to 3 from left, okay, coming close to 3 from left side, like this, by keep on increasing the x value coming close to 3 now. Suppose x is 2.9, I take it, then what I get, y value 5.9, 2.9 plus 3, 5.9. When I take 2.99, then I get 5.99. When I take 2.999, I get 5.999. And when I take 2.9999, I get 5.9999, like this. That means when x value keep on increasing, the y is also increasing, coming close to 6, right. So, when x is coming close to 3, the y value keep on increasing and coming close to 6 here. So, what I can write now from this discussion? So, limit of the function f(x) when x is coming close to 3 from left is coming close to 6, and this limit we call it is left hand limit, LHL, left hand limit, and this is a right hand limit. When this LHL and RHL both were existing and equal, then we say that the limit of the function exists. So, finally, from these two conclusion, what we can write, limit of the function f(x) when x is coming close to 3 is 6, we write. Okay. This is called limiting value. This is called limiting value. When we just straight away substituted 3 in this, what happens here? 9 minus 9, 0 by 0 we are getting. It is indeterminate form. Okay. Exactly at 3 what happens we don't know. But when x is coming close to 3, we were able to find out the limiting value is 6, right. So, it is one of the good example to understand more clearly about the limit, right. I hope you understand still better how the limit works. So, one more question we take, y is equal to f(x) is equal to, y is equal to f(x) is equal to 1 when x less than or equal to 0, 1 when x less than or equal to 0, 2 when x is more than 0. Okay, this is the function given. See, always try to observe the function, okay, where the function is changing, at what points the function is changing, okay, how they defined, you have to identify clearly, okay, otherwise you can't solve the problems. First try to understand how the function is defined. That means for all the negative values, the function is defined as 1. For all x positive values, they have given f(x) is 2. That means when we draw the graph, okay, this is x 0, x dash, okay, like this. Okay. Now, for all x negative values, the given f(x) is 1 and including 0 also. That means suppose here is 1, we take it. Okay, this is the place. When x is equal to 0 also they have given 1. That's why I have shaded here. It is a thick dot. Thick dot means in the graphical representation it is included. Okay, for all the negative values it is 1 they have mentioned. And next, for all x positive more than 0, the function is defined as 2. Suppose if we take here this place, this is 2 here, like this you get. Okay, so this is the graph of this function. It's simple function, so we can able to draw the graphs, because by graphical representation we can understand more clearly. Now I want to know the limit of this function f(x) when x is coming close to 0 is what? Okay, when you are working at some point, you just observe the function, how it is. The left side of 0, how the function is, and right side of 0, how the function is. See that you can approach 0 from left side. When you are coming close to 0 from right side, at the time the y value is a fixed it is, it's constant it is. It's coming close to 2 it is, right? It's coming close to 2. When you are coming close to 0 from right side, the y value is a fixed value, it is always 2 only. That means it's a 2 you are getting. But when you are coming close to 0 from left hand side, the y value is fixed it is, it's a 1. That means what I can write now, so limit of the function f(x) when you are coming close to 0 from left hand side, when x is coming close to 0 from left hand side, you are getting 1. And the same way, limit f(x) when x is coming close to 0 from right side, what you are getting? You are getting the value 2 it is. Okay, so the left hand limit you got 1, right hand limit you got 2. Both the limits were existed, but they are not equal. They are not equal. That's why what we conclude now, limit of this function when x is coming close to 0 is not existing. So we'll conclude limit extends to 0, f(x) does not exist, doesn't exist. Okay, right? Are you clear? So different values they are giving. Left hand limit one value is giving, right hand limit another value is giving. So that's why we say that limit does not exist. We take one more example. So y is equal to f(x), it is like this, x minus 2 when x is less than 0, is equal to 0 when x equal to 0, x plus 2 when x is more than 0. Like this the function is given it to you. Okay, and they are asking us to find out limit extends to 0. Limit extends to 0 f(x). Okay, limit extends to 0 f(x), we need to find it out. See that again the function, observe the function how they have defined. For all negative values the function is x minus 2. For all positive values the function is x plus 2. When x equal to 0 it is 0. Like this they have defined. So when you take the graph, y is equal to x minus 2 for all x less than 0 it is x 0 x dash y. Okay. When x less than 0, x minus 2 they have mentioned. That means when x is 2, what do you get the value here? Sorry, when x is 0, it come close to minus 2. That means somewhere here it's a whole, because at 0 they mention it is 0. And for all negative values they have mentioned it is y is equal to x minus 2. We get the graph like this. You just keep x is equal to minus 1, then you will get what? Minus 1 minus 2. You will get minus 3 somewhere here. If you take minus 2, okay, then you will get the y value is minus 2 minus 2, minus 4. Okay, like this you get. This is somewhere minus 1, minus 3 if you take, and this point is minus 2, minus 4, like this, the graph you get. And for all positive values they give an x plus 2. That means you may get from here. Okay, for all positive they mention clearly. Okay, right? So you will get the graph like this. This is y is equal to x plus 2. Okay, so when x is 1, the y value will be 3 somewhere here, 1 3 this point is. Okay, when x is 2, you will get the point is 2 4. Right, here also I mentioned here minus 1, minus 3, minus 2, minus 4. Okay, we are getting the graph like this. Now here also you observe it. When you are coming close to 0 from left hand side and right hand side, you observe it, what you are getting. From left hand side, you are approaching to 0. At the time, the y value is coming close to minus 2, coming close to minus 2. But when you are coming close to 0 from right hand side, it is coming close to 2 it is. Okay, it is coming close to 2. How we write now? Limit x tends to 0 from left hand side, fx is coming close to 0 from left hand side, it is coming close to minus 2. And limit x tends to 0 from right side, fx, you are getting plus 2. See that here? Okay. So that means left hand limit you are getting one value and right hand limit one value you are getting. So that's why left hand limit is not same as right hand limit. So that's why limit does not exist. Okay, these are all the questions you studied in first PUC. We are just recapitulating everything, because if you are not having idea about this, then continuity you can't do it. Okay, entire thing is based on the limits concept it is. Okay, first of all, these are all the simple examples where we can draw the graphs. Those things only I am taking. Okay, right? I hope you understand here. So when it's 0, it's 0, thick dot I kept. When x is minus 1, it's a minus 3. When x is minus 2, y value is minus 4. And when we join it, the graph it comes like this. Here also, okay, y is equal to x plus 2. These are all straight lines, right? When y is equal to 1, x is 1, y value 3. When x is 2, y value is 4. So 2, 1, 3, 2, 4. When we join it, it goes like this. So it's very clear from the graph, right? So here also we say that limit does not exist. Limit x tends to 0, fx does not exist. Okay? So this is the limit concepts. Okay? It is completely based on the function how it is defined. You just observe it carefully. Okay? Then you take the steps format. You don't need to draw in all the problems the graphs. Okay? It is very difficult also, because these are all simple problems. We are drawing the graphs here. But we have to develop something here, some knowledge on limits, so that without drawing the graphs also, we have to work it out. What else we have learnt in first PUC? Algebra of limits also we have studied. Algebra of limits. What is this algebra of limits? What are the things we have learnt? In algebra of limits, if we take f and g or any two functions, f and g or g, or any two functions such that limit x tends to a fx and limit x tends to a g of x exists, then what are the things we can write? Then first point, limit x tends to a fx plus g of x, limit x tends to a fx plus g of x, which is equal to limit x tends to a fx plus limit x tends to a g of x. And the second point, that means what is the first point? Limit of sum of functions will be sum of limits of individual functions. So limit x tends to a, limit of difference of functions is equal to difference of the limits of individual functions minus limit x tends to a g of x. And third point, limit x tends to a f into g of x is equal to limit x tends to a fx into limit x tends to a g of x. Okay, limit of product of functions will be the product of limit of functions. And the fourth one, limit extends to a, fx by g of x. Okay, limit of quotient of two functions fx by g of x will be limit extends to a fx divided by limit extends to a g of x, provided, here condition is there, provided, because in the denominator is there value, something value is there, provided limit extends to a g of x not equal to 0. Okay, otherwise we can't find out. And then the fifth point, limit extends to a lambda times fx. Here lambda is some scalar it is. So it will be lambda times of limit extends to a fx. Okay, lambda is some scalar. Okay, lambda is some scalar it is. Okay, these are the algebra of limits. Right? So these are the points we have learnt in first PUC. And then limit of a polynomial also we will see. Limit of a polynomial. Limit of a polynomial. So you all know polynomial means. So an expression of this form, p of x is equal to a naught plus a1x plus a2 x square plus a3 x cube, so on, an x power n is not equal to 0. Suppose it's the nth degree polynomial it is. Okay, this is the polynomial. I need to find out limit extends to a p of x. Okay, limit extends to a p of x. X is the variable here. Okay, when x is coming close to a, then x is coming close to a only. When x is coming close to a, what about x square? X square come close to a square. When x is coming close to a, x cube come close to a cube, right? When x is coming close to a, x power 4 close to a power 4. Likewise, when x is coming close to a, x power n come close to a power n it is. Okay, right? So the same thing we apply, limit extends to a, the entire function if you write a naught plus a1x plus a2x square a3x cube, so on, an x power n. So by algebra of limits we can write limit extends to a naught plus limit extends to a1x, limit extends to a2x square, limit extends to a3x cube, plus so on, limit extends to an x power n, right? Now limit of a constant, it is always constant only, right? It won't change. It is a fixed value. There is no variable to change there. And then a1 is a constant, I have told you already. a1 is a constant here. Then when x is coming close to a, it is a value, plus a is a constant we can write outside, because the fifth point I have told you, lambda into fx, limit extends to a, right? So in that case, lambda times of limit extends to a fx we can write. a2 into a square will get a3 into a cube, so on, an into a power n. So this is nothing but p of a. Okay, this is nothing but p of a. So whenever you have a polynomial, okay, straight away you can write limit extends to a, p of x will be p of a. Okay, so remember polynomial function is defined in the entire real number system. Okay, it is defined in the entire real number system. That's why you can just simply substitute x equal to a in that, you will get a finite value p of a whenever it is a polynomial. Okay, limit extends to a, p of x will be p of a. And when it comes to rational functions, limit of a rational function. So rational function means if fx and g of x be any two polynomials, okay, rational function, fx and g of x are any two polynomials, then fx by g of x we can call it as a rational function. Okay. So, here g of x is not equal to 0, this is fx by g of x is not equal to 0. It is a rational function. Whenever you have rational functions, you need to find out its limit. Suppose limit x tends to a, then what we do? We apply limit x tends to a fx and limit x tends to a g of x. But you have to see that limit x tends to a g of x should not be 0. If it is 0, we can't identify this, right? That is why here you have to be careful about the denominator. Okay? So, when you substitute, suppose the a value in this, suppose you substituted a and you substituted in the denominator also f of a by g of a, you got it, f of a by g of a it is. This one is finite value, that will be the answer. If it is a finite value, that will be the limiting value. If you are getting like this 0 by 0, if you are getting like this 0 by 0, that means the a will be a factor of f of x. We are discussing only on polynomials, remember that fx and g of x are any two polynomials. I am mentioning it to you. Okay. So, you are getting 0 means definitely x minus a is a factor of the function fx, that means polynomial function, and x minus a will be a factor of g of x, and then you can identify those common factors x minus a, and if you cancel it, then you can avoid this 0 by 0. You can avoid it. Okay. Are you clear? So, we have a remainder theorem and factorization theorem, right? So, we have a remainder and factorization theorem. Suppose if we are having a polynomial fx, you are dividing with x minus a. Okay. Then remainder is given by f of a. If f of a is 0, okay, then we say that x minus a is a factor of fx. Okay. Whenever you get like this 0 by 0 in rational functions, what do? Identify that x minus a common factor in both and cancel it so that you can evaluate. For example, I just give one question to you. Limit x tends to 2, x cube minus 4x square, plus 4x divided by x square minus 4. Okay. I just simply substitute. I told you because these are separately, this is a polynomial, this is also a polynomial. It is a cubic polynomial, it is a quadratic polynomial. So, if it is simply polynomial, you can substitute straight away, I told you, right? Limit x tends to a, p of x is p of a when it is a polynomial, right? But now it is a rational function, it is. That is why we should be careful. So, when I substitute 2, what I get here? 2 cube minus 4 into 2 square plus 4 into 2 divided by 2 square minus 4. Numerator what I am getting? 8 minus 16 plus 8 divided by 4 minus 4. That means you are getting 0 by 0 form. You are getting 0 by 0. That means definitely x minus 2 is a factor for each of them in the numerator and denominator. Now, you try to identify that x minus 2. So, limit x tends to 2, we factorize this, x we take common, x square minus, okay, 4x plus 4 divided by x square minus 4 we can write as x minus 2 into x plus 2. So, limit x tends to 2, x into x minus 2 the whole square it is, right. So, x minus 2 into x minus 2 divided by x minus 2 into x plus 2. As x is coming close to 2, you can cancel this x minus 2, x minus 2. And then when you substitute here 2 into 2 minus 2 by 2 plus 2, you are getting 0 by 4, 0. It's a finite value now. Okay. So the answer is 0 here, right? So, but when you straight away, when you substitute 2 here, you are getting 0 by 0. Okay, 0 by 0. That means x minus 2 is a factor for both of them, right? That we have to cancel it. We cancelled, and then finally we evaluated. We got the answer 0 like this, right? So one more problem we'll see in this category. Limit x tends to 2 x cube minus 2x square divided by x square minus 5x plus 6. Substitute 2 in this, you are getting 8 minus 8, 0 divided by, here also 2 square, 4 minus 10 plus 6, again 0 it is, 0 by 0. That means definitely x minus 2 is a common factor for the numerator and as well as denominator. So limit x tends to 2, if you take x square common in this, x minus 2, because x cube minus 2x square is there, so x square you can take common, and factors here x minus 2 into x minus 3. So now this x minus 2 get cancels, then what is remaining? Limit x tends to 2, x square by x minus 3. So what happens? 2 square by 2 minus 3, that means 4 by minus 1 minus 4 we are getting, right? So this is the limit of rational functions. We do like this, and whenever common factors are there, we identify those common factors and we cancel those and try to evaluate the limit. And what else we have learnt in first PUC is 2 more formulae you have learnt. Just I write it and then we'll stop this session. So limit x tends to a, x power n minus a power n by x minus a, it is n into a power n minus 1. This is the formula we have learnt, and also we have learnt limit theta tends to 0, sin theta by theta is 1, limit theta tends to 0, 1 minus cos theta by theta is 0, limit theta tends to 0, tan theta by theta is 1, and limit theta tends to 0, 1 minus cos theta by theta square is 1 by 2. So these are the formulae we have learned in first PUC, right? So you just recall these things and what kind of problems we have done, we know it is. And for this to work it out, I will just give you limit x tends to 1, x power 15 minus 1 divided by x power 10 minus 1, you just work it out. Okay, so based on this I am giving, and limit x tends to 0, square root of 1 plus x minus 1 divided by x. Okay, these two problems based on this, and based on this formula also I just give 2 questions. Limit x tends to 0, sin 4x divided by sin 2x, and limit x tends to 0, cos x by pi minus x. Okay, these are the 2 problems based on these things, limits of trigonometry. So we have completed the entire limits topic which we have learnt in first PUC. I hope you got the entire knowledge on limits. Then we'll go further continuation called continuity topic. Okay, thank you.